Hello everyone. Today my team and I will give you an insight in Fabry disease and we'll try to explain the molecular mechanism behind it. Today we have Dr. Xander with us, who's going to explain to us the case of Yele, as well as the scientist Sadaf who will explain the results of the laboratory. To begin with, Jelle is a 34-year-old male living in Amsterdam. And Jelle tends to be a very physical person, enjoying physical exercise and activities. So a couple of days ago, during his regular jogging routine, he started feeling extreme pain. And by the time he was home, he started showing flu-like symptoms like fatigue, fever, and dizziness. What is more, Jelle starts seeing some red spots within his abdomen that he already had since a couple of years ago, but they start progressing more and more. So he started being more concerned about it. As a result, Jelle decided to visit his GGD for an appointment. And after the doctor witnessed the red spots on Jelle's skin, he thought it would be wise for Jelle to do a blood sampling test as well as an NJ assay test. Now Sadaf will explain to us the results of the testing.
So basically what we found was that Jelle's blood sample results were normal. I saw an abnormality in the levels of an enzyme called alpha-galactosidase A. When performing the enzyme assay test, specifically Jelle had almost no alpha-galactosidase A enzymes.
So after the report of the results of the testing, the practitioner seemed somehow confused because throughout his whole career, he has never seen a similar abnormality before. And he thought that the case is very rare, and he started searching about it so he could educate both himself, but also his patient, Jelle. And he came up with the following definition.
Yeah, so Jelle has a serious genetic metabolic disorder that can lead to life-threatening heart and kidney problems. It's a progressive disease that worsens over time. The disease is caused by a genetic mutation and it's an inherit in an X-linked manner. It's one of the about 50 diseases that's classified as a lysosomal storage disorder, LSD, in which the genetic variation disrupts the normal activity of the lysosomes in a human cell. Both males and females can be affected by the disease, but it's more common in male due to the fact that it's an inherent in X-linked way. This also causes the fact that males tend to have much more serious symptoms than females, but it's possible that females have a serious disease progression too.
So after Dr. Xander provided us with a definition of Fabry disease, he also wanted to explain to us how the biochemical pathway works. So
Yes.
the following definition.
Yeah, so GL3 is a natural present in the body and consists of carbohydrates and fats. GL3 is normally broken down by the enzyme of alpha-galactosidase A. This enzyme breaks down GL3 and makes sure that it can leave the cell. However, when the body does not produce enough alpha-galactosidase A, the GL3 will pile up in the lysosomes of the cell, which will cause damage to those cells. And this is the case with people in people with Fabry disease.
And here we can see the schematic representation of what Dr. Xander just explained. So basically we can see that GL3 cannot be degraded by the enzyme when it's not there, and therefore it leads to the pile-up within the lysosome. So as for the symptoms, Dr. Xander tried to make some easy-to-read notes for Jelle to understand his condition. So first we have the classical type, which starts in childhood and progresses throughout adulthood. The child's first symptoms have to do with burning, tingling, and pricking, and neuropathic pain in their hands and feet, as well as the inability to sweat. As for the more physical features, the first one we'll talk about is Cornea Verticala. As shown in the picture on the left, it's basically the progression of brownish streaks within the cornea of the eye, which is caused by the GL3 buildup within the lysosome, and the main outcome is vision problems. As for the gastrointestinal pain, it usually causes problems with the stomach, that leads to diarrhea, nausea, and also vomiting. And lastly, as we also explained, Jelle was shown some red spots at his abdomen. And those spots are called angiokeratomas, and they're usually appearing throughout puberty and start becoming more and more after some years. As for the non-classical type, that happens to be the type that Jelle has, it basically has the same symbols with the classical type. The main difference being that it progresses later in life, so either in puberty or around the age of 30, and therefore there are no symptoms of the disease as a kid. What is more, if the disease stays untreated, it can lead to serious health issues, including heart enlargement and heart arrhythmia, as well as kidney disease. And what is really necessary to be mentioned is the diagnosis that differs between male and females. In the case of males, the diagnosis is happening throughout the blood sampling test, which basically measures the amounts of alpha-galactosidase. So in the classical type, there is no enzyme alpha-galactosidase. However, in the non-classical type, there is a little bit of alpha-galactosidase, but not enough. However, in the case of females, a blood sampling test is not always useful due to the fact that females can have Fabry disease with normal levels of alpha-galactosidase. So in this case, a gene analysis of the sequence is preferred. Now for the treatment, Dr. Jelle will explain to us the current treatments and some research that has been doing for future treatments.
Yeah, for the treatment, a multidisciplinary approach is needed to treat Fabry disease. It mostly includes intravenously administered enzyme replace therapy or oral chaperone therapy. However, lifestyle modifications could enhance the results of the provided treatment. ERT includes the replacement of the existing malfunctioning enzymes with working enzymes. For this type of therapy, it's necessary that every 2 weeks for the rest of your life, the enzyme will be injected in the veins. Oral chaperone therapy is called Galafold. When Galafold binds to the faulty alpha-galactose, it shifts the defaultly folded enzyme to the right conformation and making a fully functional enzyme. There's some research going on regarding the gene therapy, where they are trying to put the genes responsible for coding for the alpha-galactose enzyme into another organ. The goal of this research is led to other organs produce alpha-galactose. Another ongoing research is genetically modifying stem cells that Fabry disease patients can produce alpha-galactose themselves.
And also in regards to that, we can see the schematic representations of how the techniques work on the right side of the slide. So with this, we'd like to end our presentation. We hope that the insight of Fabry disease was clear, and we also hope that Jelle's case is going to be treated in the best possible way. Thank you very much for your time.